Here we have a second situation where the man has to cross the river in the shortest time. He has to cross the river in the shortest time. So how he has to row his boat, or how he has to make his strokes so that he can cross the river in the shortest time. I don't know the situation. So what I will do is, let me assume, let him make some angle. Let him make some angle. This is the speed of the man with respect to the water stream. And let us say, let him make some angle theta with respect to the vertical. I don't know how he has to cross the river in the shortest time. I have just assumed. I have assumed, let us say his velocity, correct? The speed of the man with respect to the water stream is making an angle theta with respect to the vertical. Now what I can do, I can definitely resolve B into two components, one horizontal and then one vertical. And I know this will be the cos component, V cos theta, and this is nothing but the sine component, V sine theta. Now, if I have to calculate the time taken by the man to cross the river, what will be the time? I can use the equation velocity equal to displacement by time. This implies time is equal to displacement by velocity. As I told you, you need to take that displacement and that velocity which are in the same direction. So if I take displacement as d, which is the velocity which is in the direction of d, the velocity is nothing but v cos theta. So I have to take v cos theta. This is the time. I have just assumed. I have just assumed. Let us say, let him make some angle theta with respect to vertical and then move. Now here the question tells that he has to cross the river in the shortest time. Shortest time means what, people? Shortest time means minimum time. Shortest time means what? Minimum time. And if time has to be minimum, then this denominator should be maximum, because they are inversely related. This implies cos theta must be maximum, and the maximum value of cos function is 1. Maximum value of cos function is 1, and that will happen at 0 degree. That will happen at 0 degree. What is theta here? Theta is the angle made by whom? Theta is nothing but angle made by the velocity, correct? Made by V with the vertical, made by V with the vertical. But here, after seeing the condition for the shortest time, how much angle I got? I got it as 0 degree. That means V has to make how much angle with respect to vertical? V has to make an angle 0 degree with respect to vertical. That means he has to move straight like this. If he is moving in this direction, then the angle made by the velocity with this line will be equal to 0. So let us draw the diagram now. Let us try to draw the diagram. So we got to know that angle made by V with the vertical must be 0 degree. That means he has to travel straight like this. He has to travel straight like this. This is the speed of the man with respect to the water stream, and water is also flowing in this direction. As we saw in the previous case, we will fix the direction of u. U is nothing but the speed of the water stream, which is flowing in this direction. So what will happen? So the resultant of this and this, the resultant of the two velocities, these are like two vectors represented by two sides of a triangle taken in the same order. The resultant is represented by the third side taken in the opposite order. So the resultant of this and this will push him to go in this direction. The resultant of these two will push him to go in this direction. This will be the resultant speed. So ultimately, if he's starting here, so he will reach somewhere here. He will reach somewhere here. So there will be some drift. There will be some drift. He expected that he will reach here, but he will be reaching in this direction, and he will reach over here. This will be the final point, and this will be the initial point. See, be very careful. Shortest path doesn't mean shortest time, and shortest time doesn't mean shortest path. These two are completely different situation. In the previous case, what we did is shortest path we did. For that, he has to make an angle theta with respect to the vertical and then rho. And for shortest time, he has to directly go straight, isn't it? Now you can use the Pythagoras theorem. You can calculate the resultant speed. So VR is nothing but the resultant speed. And how do you calculate resultant speed? I can use the Pythagoras theorem. So VR square is equal to U square plus V square. So this implies VR is equal to root of U square plus V square. This is equation number 1. What will be the second point? Time taken by the man to cross the river. Second point is time taken by the man to cross the river. What will be the time taken by the man to cross the river? So again, we can use the same equation, velocity equal to displacement by time, because there are no accelerations involved. And we know we have to use this equation if acceleration is 0 or if V is constant. Here there are no acceleration involved, speed is constant, so I can safely use that equation. So I have to be very careful that displacement and velocity must be in the same direction. Here displacement, if you're taking d, then the velocity which is in the direction of d is nothing but v. As you can see clearly here, in the direction of d, the velocity is nothing but v. It is nothing but what? It is nothing but v. Therefore I'll write it as d divided by v, equation number 2. And then there is some horizontal drift that we can calculate. X is nothing but what? Horizontal drift. How do we calculate horizontal drift? When he reaches there, what is the net horizontal drift? Again, I can use the same equation, velocity equal to displacement by time. Therefore, I need to calculate horizontal drift, which is displacement, which is equal to velocity multiplied by time. But I need to be very careful that displacement and velocity must be in the same direction. If I'm using displacement as x, so what is the velocity along x? What is the velocity along the x-axis? It is nothing but u. It is nothing but what? U. For calculating the time taken by the man to cross the river, if you had taken d as the distance, that is the width of the river to cross the stream, here the velocity that is in the direction of d was v, and in the direction of x, the velocity is nothing but u. So velocity is nothing but u into time. Time we have already calculated it as d by v. This is the horizontal drift.